In this video, we'll talk about doping. Doping is a process to modify silicon's electric property, such as conductivity. First, let's look at N-type doping. First step is to prepare a pure silicon ball. Next, prepare group 5 element and diffuse it to the pure silicon. Then ideally it will look like this figure. And this is N-type silicon, and 4 conduction electrons from group 5 element will form a covalent bond. Then how about one remaining electron? Here, fifth valence electron is likely to move nearly free. As a consequence, N-type silicon will be electron rich. Let's apply E field. Think about we apply a voltage across the bulk, and the E field will form this direction, and we can write J equals to NQ mu N E plus PQ mu P E. And we have to know that N is very large quantity compared to P, so we can approximate this as NQ mu N E. What is the main cause of current? Well, this formula shows that N, so electron is the main cause of the current. So we call electron as a majority carrier and hole as a minority carrier. Second, let's look at p-type doping. Prepare pure silicon and diffuse group 3 element. Let's say we doped boron. Boron will diffuse into the silicon lattice and form a bond with silicon atoms. Then ideally, it will look like this figure. All valence electrons of group 3 atom will form a covalent bond, but one valence electron from silicon will remain. One electron is missing here, thus the hole is generated. Hole will move through the bond like this. So, as you can think, compared to electron, you can intuitively think that it will be slower than electron. In fact, mobility of electron is about 3 times to the hole's mobility. Finally, let's apply E field, and let's say J equals to NQ mu NE plus PQ mu PE. And since the P is much larger than N, so we can approximate this to PQ mu PE. What will be the majority carrier? Since most of the current is generated by holes, the majority carrier is a hole. Also, the minority carrier is an electron. So let's wrap it up. P-type majority carrier and minority carrier, N-type majority carrier and minority carrier. P-type's majority carrier will be hole, and minority carrier will be electron. N-type's majority carrier will be electron, and minority carrier will be hole. So as you can see at video 1, I talk about formula J is equal to sigma E, and this equal to NQ mu N plus PQ mu PE. So p-type doping is a process that increases P and increases sigma. Also, N-type doping is a process that increases N and thus it will increase sigma. So two types of process are all called doping and p-type process, n-type process. They're all important, so you have to remember this, and this will be the basic building block of all semiconductor devices. In the next video, we'll talk about electron and holes and space charge. Thanks for watching.